Hello, everyone. Good morning, good afternoon, and good evening. Greetings from the International Telecommunication Union, ITU, the United Nations Specialized Agency for Information and Communication Technologies. We're also the organizers for AI for Good, in partnership with 38 UN sister agencies and co-convened with Switzerland. Welcome to the AI for Good webinar on AI-powered decision-making for disaster recovery. I'm Dr. Bilal Jamoussi, and I serve as the chief of the ITUT Study Groups Department. I have the privilege of introducing and moderating today's webinar, during which we will learn how AI is an invaluable tool for conducting recovery activities in the event of natural disasters. But let us not forget that by implementing AI in the other phases of the disaster management cycle, mitigation, preparation, and response, we can dampen the cost and even alleviate the need for many recovery measures. To explore the potential of AI for these other disaster management phases, including one, how AI can be used for real-time detection of events like floods or tsunamis. Two, how AI can assist with the forecasting of events like volcanic eruptions or hailstorms. And three, how AI can contribute to effective communication during events through, for instance, hazard maps, decision support systems, or chatbots. The ITU has partnered with the World Meteorological Organization, WMO, and the UN Environment in the focus group on artificial intelligence for natural disaster management. If you are interested in learning more about this focus group, which is laying the groundwork for standards in the use of AI for natural disaster management, please visit the link that will be posted in the chat. While the focus group is looking into the application of AI for disaster preparedness and mitigation phases, this webinar will examine how AI can be leveraged for precise and effective humanitarian response and recovery operations, along with conducting relief network assessment to support communications, enhance situational awareness, and improve execution of search and rescue operations in diverse disaster scenarios to reduce loss of life and property. We have a distinguished set of speakers today, and as always, we're counting on you, the participants, to help create an engaging discussion. Before I give the floor to our esteemed panelists, let me initiate today's webinar with a couple of housekeeping rules. We would like to encourage your active participation today, and we would like to invite you to use the chat and the Q&A function to communicate. We will identify and read out relevant questions to facilitate the discussion today. We're counting on your active participation to create a very interactive session. And speaking of being interactive, we have the first task for you. I would like to ask everyone to use the chat function to type where you're connecting from, and we already see some colleagues doing that. Simply type the city name or the country where you're connecting so that everyone can see it, and use everyone, not just the panelists. Without further ado, I'd like to welcome the first panelist, Dr. Robin R. Murphy, who is the Raytheon Professor of Computer Science and Engineering at Texas A&M University and a director of the Center for Robot-Assisted Search and Rescue. Dr. Murphy, the floor is yours. Thank you.
Well, as we say in Texas, howdy. Thank you very much for having me here. And I'm going to talk about robotics, which is perhaps a bit odd, but is a part of AI. But first off, I just want to tell you, I'm part of the Center for Robot Assisted Search and Rescue, and we specialize in assisting emergency managers and government agencies. We've been to inserted different types of ground, aerial, and marine robots to over 30 disasters in 5 countries and have trained many agencies in many countries. But the big point is, what about robots? Robots as part of AI. Well, when we think of robots, let's think of the ones that are actually being used for disasters. They're small ground robots that fit in backpacks that can be taken to earthquakes, small and expensive aerial systems used for floods and other things, underwater surface vehicles, which makes a lot of sense when you think about all the ports, all the bridges that get impacted by flooding, tsunamis, earthquakes. Robots have already been used for almost every disaster you can think of and every objective, from the floods, earthquakes, tsunamis, wildfires, volcanic eruptions, nuclear accidents, chemical spills, and pandemics. Robots are actually being used in all sorts of ways for COVID. When we think about AI, though, I want you to think it may not be what you're thinking of as robots. So we saw from the DARPA Robotics Challenge, and you think of robots replacing people, that you give them a task and they go in the building and save somebody and come back, or they do something and come back. Don't think of them that way, because that's really not how they're being used. That's called taskable agency. They're sort of an agent that you can tell what to do. What we find, the predominant use of any of these robots is for remote presence. Go places people can't go to, see things that people can't see, and do things that people can't do safely. So it's all about getting the right information you couldn't get any other way. And of course, that means we've got to have AI to process that information. So if you look at just the recovery phase, the recovery, not the response, because the response phase is what everybody thinks about robots to help with the life-saving part, but just about that, being able to monitor and detect the environmental dangers. We find a lot of sewage leaks, oil spills, things that with an aerial vehicle in a flood or after a hurricane, what that means, you've got to find that source and get it before it ruins the environment. Supporting relief efforts. I mean, a country like Haiti cannot live off of planes coming into one airport. You have to reopen the ports. If it's an earthquake, those shipping channels may have changed. Those ports all the docks may have changed. There may be that underwater portion may actually not be connected to the ground anymore. So we have to check that. Accelerating economic recovery, the damage documentation, the assessment, correct assessment of critical infrastructure such as roads and bridges, and then providing social support. I mean, we're seeing lots of this now, particularly with the pandemic, of robots being able to interact socially and help bridge gaps when we can't be with people. Another thing to keep in mind is the data coming from robots may be very different than what we think about AI working with us as a data science. Here, the data is much more image, video driven. So you're putting together these large maps, these 3D elevation terrain measurements, these complete reconstructions of buildings and collapses. So that's very different than kind of the data mining we typically see in AI. Very valuable. And what's even more surprising, I think, is how much data we have to handle. If we look at the Surfside collapse in Miami, Florida, that was only one building. The recovery phase was about 2 weeks long, nearly 350 gigabytes of data. And worse, yes, if you're thinking about wireless communications and restoring that, you're looking at a burst of 50 gigabytes, having to go up daily, burst of 7 gigabytes, at a time. And that's a big load. And that's only one building. So imagine a big earthquake like a Mexico City collapse or something like that. So let me just wrap up here really quick. what can AI do? Well, I think that AI, its first best use is getting the right information, not just data, information, which means it's in the right visualization, and get it to the right person in time for them to make that right decision that can give us the greatest good, the greatest outcome. And two things that we need to look at, I think, as more is using AI at the edge to keep us from having to upload everything into the cloud or making it where you've got a 300 megabyte image that nobody can email or get to, and may not have enough computing power because they're in the middle of a disaster or they're in an underdeveloped country. And also to think about AI not as replacing people, not as decision automation, but as decision support and assistance. If it can do 70% of the classification of buildings are damaged, the person does 30%. That's a huge win in time and effort. So we want to see those solutions as well. So think about those, and just remember, anything we can do at CRACE, the Center for Robot Assisted Search and Rescue, to help, we will. Just let us know. So thank you.
Thank you very much, Dr. Robin. Dr. Murphy, response and recovery, the key messages I retain is lots of data. You need an incredible communication network, and you want to apply AI at the edge, because that's where time is critical, and that's where you can get the best timing to help the teams with the real-time information and guidance. Thank you very much. We will now move to the second panelist, Dr. Sharma, who serves as the scientist and group director for the VIDAS research group at the Indian Space Research Organization, ISRO. Dr. Sharma, the floor is yours. You're on mute. If you can unmute your line, please. Please unmute your line, Dr. Sharma.
Yeah.
Thank you. Go ahead.
Yeah. Thank you all. So we'll be talking about the AI-powered decision-making for disaster recovery. We know that we need fast and accurate situational information, and we also need to know the location, cause, and severity of the damage, because we want to prepare ourselves for the recovery. So there are some of the good examples, like AI can be used in mapping the nature and type of assistance is required. So here, human material and resources are very less. So we can use some social media platforms like geotag text, use NLP, and use geomedia photos, do image classification. So based on that, we can find out where the areas need medical assistance or fire rescue services are required, or where there is a water or food shortage. Also, using drone and satellite imagery and using social media photos, we can find out the best evacuation route, which can be used to evacuate the people or to bring the supplies and all those things. Also, we can have very high resolution satellite data. We can generate 3D city models, which can be used for infrastructure damage detection and for quick response. So this AI-based image classification using high resolution data is possible, and this type of 3D city models are very useful. Also, this can be a high resolution digital elevation model together with the 3D city model can be used to find out where the flood area is there and which are the buildings which are quite affected or which are prone to disaster and flooding. So that evacuation plan and all those safe buildings can be known. Very high resolution data are used to find out the damage due to earthquake, and also CNN based applications are now available, and we can find out where the disaster has occurred, which buildings have been damaged. So that will be very useful for disaster recovery. Also, it is very much useful for landslides. So during the earthquake in Japan, this AI-based landslide detection was used, and it was very fast and accurate as compared to human interpretation. Also, using models, we can do the impact analysis in advance. Like for example, in Kamori typhoon in Philippines, in before 81 hours, it was it was possible to find out how much damage it will be there based on various aspects. And this will be very useful for disaster recovery, because we will know in advance that how much damage is going to be in which regions. Similarly, there are snowfalls and a lot of road blockades are available. This is an example of Indian remote sensing satellite. On 7th April, there was no snow, but suddenly there was a heavy snowfall and the roads were blocked. So this type of automatic AI-based snow area detection is available, and it is available on daily basis, and we can find out which are the areas which have blocked. So similarly, for locust effect also, locust is creating a lot of problems in Africa and Asian region. So using some machine learning classification, we are able to find out how much damage has been done to the crops. So these are all some of the applications. And in the nutshell, I can tell that AI/ML will be useful in enabling small satellite constellation to operate as network. And edge computing can be real-time decision making. And AI and big data in media communication, transaction, mobile activity can be useful to track the movement of the people. And AI-powered image recognition through drones and satellite will be very useful to find out building damages and road and flooding. Then AI-based chatbots and voice response system can be very useful during these times. IoT-based sensors with edge computing can be very helpful to find out the event well ahead. Then, as Madam has told, AI-enabled robots will be very helpful in this challenging terrain and life-threatening operation. And lastly, I can tell the use of AI-based image analysis on cloud using satellite data obtained from various countries can be very helpful. So at the end, I can tell that AI in combination with a lot of data and human domain expertise will change the way we model and manage disaster recovery. And it is very quick and accurate, but there is a caution that there is a lot of hype and sometimes overstatement of the capacities and these tools, and deployment in untested approaches in safety critical scenarios has to be seen in caution. So at the end, AI is very useful in disaster recovery. That's all. Thank you.
Thank you very much, Dr. Sharma, for your intervention and for presenting the core activities of ISRO in this domain. I'll now give the floor to Mr. Jean-Marie Boer, Senior Advisor on Digital at the World Food Programme, for his insights on the importance of AI in managing food emergencies. Jean-Marie?
Thank you, Dr. Jamousi. My name is Jean-Martin Bauer. I work for the World Food Programme in New York, and I'd like to follow up on what Drs. Murphy and Sharma have explained. I'd like to give you the perspective from a user, from someone who works with the field with these tools. I'm getting you started with a meme where you see the dog in the back sort of writhing in joy at the thought of using AI, and then the other dog in the front saying, well, let's see whether this is really for real. I'll take you through two case studies to illustrate how AI is helping WFP. We are a UN agency. We help feed 100 million people every year in over 83 countries. How do these technologies help us do our job better? The first the case studies I'd like to tell you about involves the Hunger Map Live. Oops, let me make sure you actually see my screen. The Hunger Map Live is a tool that you can find at hungermap.wfp.org. And this is something Dr. Sharma mentioned. This is about using different data streams and machine learning to predict food insecurity in places where we're not able to do surveys. And this is very, very handy in fast-breaking situations and disaster situations. The system WFP is set up is based on mobile surveys in 35 countries. We've got daily data coming in 35 countries, but thanks to an application of machine learning, we're able to have estimates of food insecurity in 57 more countries where we don't have a presence. The way we do it is we train a model with different types of data to get to that estimate of the food insecure population, and the data sets we use include vegetation, rainfall, food prices, and also the previous survey data we have. So as a result, this has really multiplied our capacity to make an assessment of humanitarian needs in places where we're not at. this has very operational implications. And I'll tell you an example of Yemen. It's a conflict setting, but it could equally apply to other types of settings. But in Yemen, there was an area of the country affected by conflict that we couldn't reach. And thanks to the machine learning, we detected a likely surge in food insecurity. And what our office in Yemen was able to do with its partners was increase the coverage of the next month's distribution and also increase the ration size. So more people got more food as a result of the machine learning that took place out of that analysis. And this is what Dr. Murphy was saying. AI is your assistant. So it helped us make a better call to help people who were in urgent need. The second use case I'd like to tell you about is using imagery to detect damage, and both my co-panelists already mentioned this. WFP has different projects that work on this, but the idea is simple: is you've got an image on the left, that's the raw image, and we have a model or different models that pick out and classify damage, and this helps us in post-disaster settings understand where the damage is, identify damaged roads, identify damaged buildings, and therefore have a better idea of what's going on the field. The projects we have at WFP, they work with drone imagery. So yes, Dr. Murphy, we use robots, but also very, very high resolution satellite imagery happens to work. And what the beauty of this is that with a 10-minute drone flight, we're able to come back with the imagery and process it in a few hours on a system on a laptop with a decent video card. That's all it takes to work. And we're able to have a detailed map of a disaster affected area, something that would have taken weeks before the application was set up. And one of the things we're actually proud of is that we were able to pass this on to government and pass these tools on to national disaster management authorities. So the picture you see here is of Mozambique. And this drone was taken by Dr. Antonio Beleza, who's the deputy at the National Disaster Management Agency there. With his drone and the AI tools, he's been able to do mapping of all flood-prone areas in Mozambique and really multiply his capacity to produce these maps. It would have taken much longer without the drones and without the AI. If you're interested in a little bit more information, we have a paper coming out on the hunger map. You might find it on archive. I will give you links to the hunger map live and a little bit more about the projects we have involving remote sensing. But to conclude, what I would like to really leave you all with 3 points. The first one is we do need a lot of data for artificial intelligence, and that data tends to be held by private companies. So it's actually quite a big deal for us, the practitioners in the field, to be able to access the data when we need it. And we really need to move to a situation where we've got unfettered access to imagery. That can involve us getting the imagery quickly and for free from data providers, or we could also take our algorithms to the data where it exists. And you can think of these big providers of imagery, but we really need to move to an open model of artificial intelligence and creating digital public goods that would help first responders. So we're a UN agency, we have these constraints, but think of the national disaster management agencies, the local NGOs. They need to be able to run these projects as well. Takeaway number two, number one was really a call for open AI. Number two, we do have a black box issue. People in the field, they've been used to doing things for a very long time in a certain way. When you come in with artificial intelligence, there's fear, there's misunderstanding, and we need to get beyond the black box. So the community here needs to be able to share, exchange, and and this webinar is a great case of us coming together to talk about what we do, and more of this is certainly needed. And finally, what I'd like to leave you with is that not everything needs to be mapped or processed. In some cases, it's quite dangerous to map and process data about very vulnerable communities, and we need to be able to manage this data and develop our capacities in AI responsibly in a way that protects everyone and that doesn't put minorities at risk, or that the data could be combined with other sources and create problems for the very people we're trying to help. And a lot more thinking is going to be needed in order for us to get this right. So I'm enthusiastic about it, but let's make sure we do it responsibly. Thank you, and back to you, Dr. Jamousi.
Thank you very much, Jean-Martin. An apology, I mispronounced your name when I introduced you. Sorry about that, but thank you for your presentation. Now it's time for Q&A, and I encourage the participants to type them in the Q&A box, not in the chat. I'll request our panelists to maybe turn on their cameras, as we will be taking questions from the audience. But I'd like to start with one. In the past, when we used to, ITU used to, for example, help countries with emergency response, it was more about dropping in satellite phones and trying to get basic voice connectivity in those sites. But what we heard today, the picture is changing rapidly, and it's quite diverse in the sources of data: drones, satellites, robots, IoT devices, social media. So there is a whole diverse set of data sources coming in. And I see one of the panelists, one of the participants is asking Dr. Murphy, how can AI resources be used in remote areas where there is no access to any form of communication? At the moment, where I work in sub-Saharan Africa, satellite phones are the only option. This question kind of triggered my recollection of how we used to manage emergency response. And now with this whole diverse set of data, maybe I'll ask Dr. Murphy to start, and also invite the other panelists if you have any thoughts on this question.
I think that never underestimate what you can do with a small drone that costs about $1,000 US dollars and a good laptop that you would use for video gaming with a good card. So I think for $3,000 to $4,000, you can do remarkable things. In fact, all of those three-dimensional reconstructions, all of the that you saw from the SUR side, those were done on a laptop, and they were flown with that type of drone. So it's now cost-effective to look at that. I think that, so don't let the idea that a lot of things are licensed to be in the cloud stop you. What you can put in the back of a car is very useful and immediate, and within 3 hours, you will have incredible amounts of data. So that's another thing that we recommend, that many times we ask that the civil engineer, the drainage engineer, the expert on the floods and what the area is, the transportation engineer, go with the drone team so that they can look immediately, both to make sure the right data is collected, but a lot of times they make a decision right then and there, becomes actionable. So you can cut down that lack of communication by making sure the assets are with the expert decision makers, the people who need to do it. So do think of that. And I want to just take just a minute to get back to the wonderful point about we used to drop things in. Now, I think that with the low cost, particularly of drones, that this idea that we're going to give people things, no, it needs to be in your hands and using it before the disaster, for the before condition, particularly with flooding, what it was before and what is after, all of those in everyone's hands right now to make it work.
Right. So it's almost like a toolkit that should be ready, which provides basic connectivity. The sat phone could be one of them, but also the drone, as you mentioned, a high power laptop, and maybe other devices that colleagues might propose as a basic toolkit for emergency response and recovery operation.
Right. You wouldn't think of sending a country fire trucks. You would expect them to have fire trucks. We need to give everybody fire trucks. So that's what I'm thinking.
Very good. Excellent analogy. Thank you. Dr. Sharma, Jean-Martin, anything to add?
I would add that, please, Dr. Sharma.
Yeah, okay. So as you know, that some of the countries do not have very good processing facilities at their end, and they will not be able to analyze a lot of data available. So, there should be a cloud-based platform wherein, satellite data are now available in plenty. So the countries which are having satellite data, they are giving free of cost. to the disaster charters. So there should be a processing platform available so that all the data can be processed online there. So what a user needs is just an internet connection. He doesn't need any software or anything, but all the things can be done. A lot of AI-based modules can be developed, and that can be used so that he can get the latest information of that area without investing into much of the what you call infrastructure for analyzing satellite data. Also, once he gets the drone image, sometimes it might be difficult for him to analyze. So if he can upload to this type of platform, then automatic AI-based analysis, what you call modules are available that can give him an analyzed or what you called better information to the users, which are quite deprived of the technologies available at their place.
Okay, thank you.
So Dr. Jamousi, I'd like to follow up on that by just saying that it's absolutely right. Preparedness is key. And in the case of Mozambique that I told you about, WFP had been working with that department of the Mozambican government for years. And when we started working with them on drones, it was before Cyclone Idai in 2019, but we had a relationship going and we were able to train and continue working with them. And again, at present, they've got that capacity. And we know that when there's a disaster in Mozambique, the next time there'll be a disaster, they'll be equipped to produce those maps independently, thanks to the low cost, the lower barrier to entry to using these tools.
Great, great. And maybe I'll pick up on that. And also Dr. Sharma, in terms of the diversity of sources of information. Dr. Sharma, you mentioned the satellite images, the need for the cloud. Dr. Murphy, you mentioned the drones and local laptops on site. And Jean-Martin, you mentioned also being prepared and having a multitude of these devices on the ground and people trained with them. Someone also mentioned the social media. So, and I think Jean-Martin, you mentioned earlier the importance of having that data being open and shared in a responsible manner. So there are some questions on the chat is where do we start, in terms of the data sharing and access, and possibly in terms of machine learning or AI algorithms that we can put in place to react or deal with a disaster from a response and recovery. So can you maybe shed some light on ways to share the data and frameworks and guidance, as well as if there is any open source implementations, machine learning algorithms that could be used by various countries participating in the webinar today?
So if you'll allow me to give you a few ideas.
Yeah.
So I use the word digital public good. That's something we use in the UN to describe a product that's free, open source, and available to everyone. And there's actually a new digital public good that was announced last week. It's there's an open drone suite that's available. So if you want to check that out, it might help you with at least using drones to acquire imagery in a way that's open, and you don't have the redundancies and the limitations of using proprietary software. But that's a tiny part of what needs to happen. And here in New York, what I'm hearing is very ambitious discussions about creating a global data commons. I like the idea, but getting a global data commons for disaster response is extremely ambitious. It's going to take a lot of time. There are a lot of legal constraints because the fact that this data comes from private companies, their data is proprietary. They do not want their competitors to see the data. There are a lot of privacy issues that are there. So getting to a global data commons is probably something that we'd like to work together to, I mean, we need to work together to get there, but it's going to be extremely complicated and involved. But certainly we do see that as the North Star, being able to make companies comfortable that their data would be hosted somewhere where the humanitarian community could access it without causing any issues in terms of their competitive power or privacy or other issues that might matter.
I'd like to jump in on there too. Jean-Martin, great point. So one of the things I want to circle back to is this idea of you keep emphasizing the data sets you're seeing are coming from companies. The data sets I'm gathering and the sets that we have are open. most of them, and they come from government officials. So basically what happens when you fly for a government agency, the data belongs to them. And normally, hopefully before, but during the thing, they realize what their public transparency privacy law should be. They scan the data, make sure there's no violations of personal privacy issues, and then post it so everybody can see why you had drones flying over them during that event. So there's a lot of open sets there, and looking at government having that. And in fact, I find in terms of flooding damage, those sets are far better than anything we've seen from commercial. They're lower altitude, they're more pervasive, and they're where more of it's there. I like the idea of the data commons. I do think that we do have to be very careful about privacy. We had a missing person search after a major flood in Texas. Volunteer groups started flying drones, then they grabbed all this data, right? So you've got what you do typically when you do a missing person search, you fly as high resolution imagery with as much overlap as that, and then everybody gets an image and looks at it. You don't need to make a big map because you really just want to look at that one puzzle piece, and then you've got the GPS coordinate. You can go back and look. Well, what they did is they say, one group said, hey, we're posting everything to Facebook. Can you tell us if you see a victim in here? And we're like, you're putting up saying, find a dead person in there without any thought of the family, any thought of and it was like, pull it off. So we don't want that to happen. So having those formal as ethical use, as John Martin said, is so important. But we have lots of flood, volcano, earthquake, all sorts of data sets. So please contact me. I don't have the link off the top of my head.
Okay, thank you, Dr. Murphy. Dr. Sharma, anything to add on this first? Yes.
What we feel that, a lot of now AI applications are there. So whosoever develops this type of AI application, so an inference portal can be developed wherein people can just put their data and they can get the output out of it. Also regarding the sharing of training data, which is very important for AI, we can develop a module wherein the user can upload his data for training the module and making it better, so that he need not share it to all, but he can, using his training data, he can improve upon the models. So as the day goes, the model will be improved, and without sharing, the user can get better models. So that type of collaborative approach from all the countries can be very helpful in developing good models, AI-based models for disaster recovery.
Yeah, but we definitely need the one-shot learning algorithms, right? Because every disaster is different. And so there's always so I want to see them also pushing on those types too. So like you said, being able to have the rapid updating.
Very good. I want to switch to another set of questions that I'm seeing in the Q&A, and they sort of deal with the extreme conditions during disasters. Low temperatures, high temperatures in volcano versus Arctic or snow areas, underwater. Some of these tools like drones perhaps are not usable underwater, but there may be other robots. So could you, Dr. Murphy, start by maybe shedding some light on these extreme conditions which tools would be more appropriate?
I'm not sure I entirely followed the question, but in extreme environments, you almost always want to go for robots because they go and do things people can't do. Certainly, if you're trying to do in an Arctic environment, commercial products often aren't built for those extreme conditions. Underwater robots tend to be more expensive because anything underwater in electronics, you have to protect them. So they just tend to be more expensive. Seawater tends to rust things. So it has to be much more expensive materials. But I think that the extreme environments, for instance, at the World Trade Center, one advantage of the ground robots that were used is that they could actually go through the parts that were still on fire from the jet fuel to try to see if there were any survivable voids or getting into spaces, trying to get to the basement where we thought there might be survivors. So robots do give you a lot, and you saw that at Fukushima as well, right? Extreme conditions.
Great, thank you. Jean-Martin, anything to add on that?
I'm not a robot specialist, but everything Dr. Murphy said sounded quite good. Thank you.
Thank you. Okay. Another question, which is more on AI versus other analytical techniques. What are the biggest advantages of using AI as opposed to the current quantitative measurement and forecasting techniques used?
Yeah, so should I answer?
Please, yeah.
So, once we develop our empirical models or any type of models, it is very difficult to, develop it mathematically. Sometimes there are so many nonlinear equations that can be fitted using AI algorithm like CNN or anything, which a normal human being is very difficult to judge. So using AI, we can do this type of nonlinear equations and they try to fit into your model. So that gives what you call a better accuracy, which we do not get using the what you call the normal mathematical models. So better the what you call training data, and the more the training data, the accurate the training data, the models will be better and better. But obviously, if the training data is not good or it is not what you call sufficient, then obviously you are going to get even the worst result than what you are getting through the things. So the training data has to be good and should be appropriate as well as should be what you call adequate.
Okay. I don't see any other panelists chiming in on this question. Perhaps back to the data, do you see a need to standardize the formats, the metadata, the interfaces to access the data? Because you want to react quickly, but if you have so many sources of data and they're all coming in different standards and different formats, that's where ITU usually tries to help, is by using these focus groups and other study groups and so on to develop some sort of framework for standardizing data, APIs, protocols. From your experience in this domain, what are the one or two standards that you think would make a real impact on advancing using AI for disaster recovery and response?
Well, if I could start, everything you said, Dr. Jamousi, about the data not being standardized, that indeed is an issue. But then there are the decisions analysts make that are also a barrier, and we need standards for classification. I was speaking to colleagues who work on our AI project for imagery in Munich at WFP's Innovation Accelerator, and they told me that they ran into trouble because they were classifying damage on the basis of a 5-point scale, while a partner was using a 4-point scale. And therefore, you just can't even compare the results. And again, a lot of this work is meant to be used by the entire humanitarian community. And if we can't even agree on standards for classification, there's an issue there. So I wanted to add that to start.
Very good point. Thank you.
As far as inputs are concerned, in satellites, we are following CEOS standards, and they are very much followed by most of the countries. So satellites which are following the CEOS standards are very easy to ingest into any other platform. I don't know about the drone data, what formats are standard, but for satellite data like CEOS and other things are available. Also, like when we disseminate the information through web, so all those OGC standards are there. So if people follow that standards, that are also consumable, and people can use the services which are OGC compliant. So that can be also very useful.
Thank you.
I'm going to take the exact opposite view. I think the standard is to expect no standards. Now that comes from my work because we work primarily with emergency management, not humanitarian groups. So those all have so many agencies. It's a very bottom-up driven process. So you very rarely get one size fits all disasters in all agencies. So we find a lot of groups come in and say, oh, we're going to use AI to revolutionize emergency response. And first off, everybody's going to fit this little set of niches. Like one group built a great program. Oh, we'll coordinate all the drones, but it'll only do the 5 most popular drones. And if anybody shows up with the 6th model, it can't be added in less than 2 weeks. So that's not working for us, right? Also, I think the AI has often underestimated the heterogeneity of the data. that comes in making important decisions. It's not just a visual classification. It's not just that it's human information, voice information, text information, visual information, all of these things which humans are extraordinarily adept at synthesizing. So the trick is to get it to them and not obsess over, hey, look, we can use computer vision machine learning, which is wonderful. I love it. But, is it a 4 or a 5? That's important, but there's also other things. If it's where you can quickly get person B, can you quickly discern 4 or 5? You figure it out. Just getting it to them may be more important. And also the thing, and by the way, this is an orphanage. And by the way, this over here is a building that has not been used, no sign of use in the past 3 years. So we don't care, right? Those are the things that we'd like to get in, the contextual too.
Maybe I'll pick up, since you have the floor, Dr. Murphy. Why does your center emphasize robot assisted as a way forward?
Because robots don't replace people. AI doesn't replace people per se. For me, for the good humanitarian uses are to assist, to help, to enable. Sometimes that means delegating, but it's always about empowering people to make good decisions, to make good actions, to take the right things, to make the world a better place.
Okay, thank you. Jean-Martin, what are your relationships with the private holders of data?
We're collaborating with some of them. We have an established collaboration with Google Research, for instance, and they've been quite helpful in working with WFP's innovation team in Munich in developing some of the analysis I've been telling you about during this this conference. Now, they've helped us with their expertise, but I think where we need to get is again to where we can unlock some of the data that they hold. Of course, if we're talking about remote sensing, there is a lot of public data out there, and I told you about the Hunger Map Live that relies on a lot of data from NASA, National Meteorological Agencies, and even WFP's own data. So we don't necessarily need private data to do what I showed you earlier on. But if you want to start tapping into mobile networks to get data on population displacements or population impacts, you're going to need to go to the MNOs. And I would say that the way we've approached those partners has been ad hoc, and it's been after the fact. And let's go back to something Dr. Murphy was saying earlier on. You need to do these things ahead of time. These agreements with the private companies need to be, you can't expect them to open up their data sets the day after an earthquake or the day after a flood. It needs to be established way ahead of time because of all the issues and the risks that are there, especially risks to privacy. So it's a work in progress. We're engaging, but there's a lot more to be done. And we're looking forward to more engagement with the GSMA, the Mobile Association, and other similar bodies. And maybe this is where ITU can help us and make sure that these data sets find their way in a way that's responsible to the first responders so they can do their work.
Certainly, and we certainly welcome your input to the focus group that will be meeting soon in terms of trying to provide a framework for pre-standards or standards just to guide how we get there in terms of data collection, storage, processing, and using AI and machine learning in various aspects of natural disaster management. I wanted to ask also Dr. Sharma on few questions that came up really show that some countries have limited resources, limited hardware, limited software, IT infrastructure to engage in these activities. What are the challenges faced in AI implementation within the disaster management and emergency management domain from your perspective for these countries?
Yeah. So right now, a lot of satellite data is available. We have a problem of plenty, you can say. But many countries do not have a proper infrastructure or the ability to analyze the data on the fly or instantly. So like international disaster charter is there. So now we are developing a processing platform so that the satellite data which are available during disaster, all the countries give the data free of charge. So that data is available on a platform wherein using cloud, you can do the analysis. So on the fly, you can generate flood maps, you can generate damage maps. So all these things are available on the fly, and a user can generate that maps just with the click, and all those algorithms are also available at that place. So what he needs is just a good internet connection, that's all. And at least he can get the basic satellite data as well as the maps generated using this models for his use. So this type of what you call a cloud-based processing platform for disaster is very good. And countries are very ready to give that data. And also he can, whatever data, suppose he gets from drone or from any other sources, that also he can upload and use the analytic platform to analyze and to add the information to it. So such type of collaborative efforts are very useful for the countries who are not having good what you call IT infrastructure.
Thank you. Jean-Martin, I think there is a question at the end of the Q&A around the liability. Do you want to say a few words on that?
Sure.
I saw you typing. Maybe you can share.
I was actually typing out a response. Thank you, Dr. Jamousi. And it's a good questions, and good questions here on how we get access to this data without compromising privacy. And something that we all need to know is that if something like global data commons is created, it wouldn't include any personal data. It would include aggregates. So indeed, if you create a new resource, you wouldn't want to create something that could cause problems for individuals. And in fact, I'm pretty sure that if we created a global commons of private data, that would first of all cause an uproar. Second of all, the companies wouldn't put any data there. It wouldn't work if it's private data. If it's a global data commons of aggregate disaster data, that's something that's much more palatable. And I think that that's probably the direction that would be taken here. I'm sure you're all familiar with Facebook's Data for Good initiative. They already serve out aggregate user data to relief organizations to help them with what they do. So that's sort of the established precedent out there. What the alternative is also just taking your algorithms to the data. So you tell the company, look, I don't need your data. Here's the question I have. Run the algorithm behind your firewall and give me the results. And that's again a way of protecting privacy. And there are probably other ways of ensuring people's privacy is respected and that we don't cause undue risk. So this is an evolving area of practice. But what I'm hoping is that privacy remains one of the primary concerns as we go forward.
Great, thank you. Thank you, Jean-Martin. There's a question about the Delphi methodology at the end of the Q&A to make strategic prospection for disasters. Do you have any methodology for AI to use it, is the question. Okay.
I think one of the problems with knowledge elucidation, what we find with emergency managers is often they're not in a good position to speculate on how data is going to be used or how things, because all they know about AI and robotics is from what they see in the movies. And that's kind of wrong. Okay, it's a lot wrong. It's a lot wrong, right? So they don't know. So they're coming, it's not like you're asking them with the technology they're familiar with. And so we see knowledge elucidation not as useful. There's some beautiful work by Dr. Gary Klein that also say people are really extraordinarily good at imagining only normal cases that we don't do as well. We fall apart at thinking of unusual cases or exceptions to the rule. And so as you know, a disaster by its nature is an exception to the rule. And so it makes it very hard for us to speculate on all the ways things can go wrong, all the needs for technology, all of the side effects such as privacy or things that could come up. We're not as good as doing that. For me, it's more important to get high fidelity exercises, really start looking, and also be aware that we are in this critical 20-year formative phase of applying AI to disasters. And we need to be on the alert to see what's working and what's not, and do that rapid course correction, just as Dr. Sharma was saying, to do that with the AI, using that to learn and rapidly adapt. So that would just be my thoughts.
Okay, thank you. I see Jean-Martin nodding. There was a question on a call for a moratorium on the use of AI on human rights privacy grounds. But I just heard you, Dr. Murphy, say the opposite. We are just starting to use AI to solve some of these problems, and we need many more years to learn and perfect these technologies. So how would you react to this call for a moratorium?
Well, I don't think that means we get to let people off the hook for using AI in a bad way.
Mm-hmm.
And even if they started out with a good intent and we discover there's a bad way, we got to stop it immediately. We've got to be able to do that. I'm just saying that we can't predict everything, and we can't predict how it's going to be used perfectly. We don't have a perfect view of the future. So we've got to try, but we've got to have mechanisms to course correct and make sure that an unexpected abuse doesn't persist.
Thank you. How are we doing with the models? How advanced are the models, the machine learning models, the AI algorithms in this domain today?
As far as classification and identification, or some finding the what you call the disaster-prone area or finding the damage, so all those things are quite matured as far as satellite data identification using drone or using satellite data are concerned. But what Murphy has said, that using all the data from various sources like text data, social media data, drone data, and many other like amalgamation of all those information and generating a real output out of it, that is still very far. So getting data from various sources and heterogeneous sources and putting at one platform and giving the final solution, that is still away.
Yes, Jean-Martin?
I wanted to add to what Dr. Sharma just said, and there was a question to this effect in the chat.
Mm-hmm.
The models we use for damage detection and classification are 85% accurate. So that's pretty good if it's to be used for an emergency. Now, if the use case were different, maybe 85% isn't good enough and you need something closer to 95%. But if it's a disaster response, we're pretty happy with that. And that really confirms what Dr. Sharma was saying. That type of algorithm works pretty well.
Thank you very much. We're getting close to the end of the webinar. I wanted to give an opportunity for each of our panelists to maybe say a few closing comments before we close. So Dr. Robin?
My one closing comment is thank you all for being here. And don't wait. Start using AI and robots now. Start learning and start sharing what you're learning so that we can really, truly make it AI for good.
Thank you. Dr. Sharma?
Yes, I do agree with Murphy that whatever we do, we should share. Sharing and is the main what you call the mantra in disaster. You share and you will always get the benefit out of it. So whatever technology or what you call models or anything you develop, please share with everybody, and that will be useful for the mankind.
Thank you. And Jean-Martin?
I'd like for all of us to get to a place where we don't fear the black box. We need to embrace AI for the good it brings. Also not be completely naive and know that there are risks, but what would help us is by doing what Dr. Murphy and Dr. Sharma said. Let's share, let's talk, and let's get to the point where we're not staring at a black box, but we understand what we're doing and we have this enlightened understanding of how this can help us achieve our missions. Thanks.
Well, thank you very much. I'd like to thank you all for your kind attention and participation today. Big thank you to you, our panelists, as well as our audience and participants from around the world, as we can see from the chat. Hundreds of participants joined us today. We're really grateful for your participation. And I know from previous experience that there will be as many at least listening to the recorded version. Because of time zones, some people are not able to join us at this time. So actually, barely a year ago, on 13 October 2020, which is the International Disaster Risk Reduction Day, we had one of our first webinars on the topic of disaster management. The discussions during that webinar paved the way for the creation of the ITU WMO UNEP focus group on artificial intelligence for natural disaster management. Today's webinar has helped us to gain an overview of how frontier technologies, including AI and robotics, can assist with disaster response and recovery operations. To take this discussion further, we also encourage you to check out our AI for Good program online to see more sessions that may be of interest to you. For example, on the 30th of November, 2021, we will have a session on robots saving lives in disaster-hit areas. We are pasting the link in the chat and encourage you to join us. I would also like to conclude now this webinar by mentioning that nature can be disruptive, but so can technology. Thank you again to our panel, our participants, our partners and sponsors that made this possible, and hope to see you again soon. Bye for now. Thank you.